Hello, welcome to our video about the proper use of a pH meter. So to start the use of a pH meter, you're going to turn on your pH meter. It's not shown in this video, but it'll be shown in a later step. You're then going to unscrew your pH probe, and then as soon as you get it, you're going to go ahead and rinse it off with some water, just regular DI water that you collect, and then you can put that in a beaker full of DI water. Now to prime it, to calibrate the system, you're going to take your first pH solution, which this case was pH of 7. You're going to click on the pH, add the pH for the calibration, first 7 for the first one. Then you're going to rinse it with DI water again in between steps so that you're not transferring pH solutions. For the next step, you're going to collect your pH 4 solution. You're going to stir it in your solution, not wanting to hit the sides or break it and everything. Then you're going to click on it again, the pH probe, click 4 for that pH, and then calibrate it and press OK when done. Next in this step, we're seeing Anya. She's going to be taking the pH of an unknown concentration of apple juice. She washed it with DI water in between the probe and is now measuring it. And we can see that that final measure is 3.38 for pH for the apple juice. Now Anya is cleaning it once again with DI water before putting it back into its cap and closing it tightly. This next few videos will be myself, Latham, and Lauren Grace repeating the process. But first I wanted, while we're watching this go through again, I wanted to talk about the weak versus strong acids. So for a weak acid, when there's a dissociation of the weak acid, it dissociates into its conjugate base. And when that conjugate base is dissociated, it's a strong conjugate base, so it likes to kind of hold on to its acid. It likes to hold on to its protons a little more. But then that weak base is also wanting its proton back, so we get a little bit of an equilibrium situation going on. When we have a strong acid, that acid is so strong and its conjugate base is so weak that the acid does not want to keep its proton. It wants to get rid of it. And that conjugate base is okay with accepting it. And we get more of a one-sided reaction with the weak acid not necessarily staying together. It may go back in the product, in the reactant favoring, but it won't last long as that strong acid just because it wants to dissociate so much in water. Some ways that you can fix this equilibrium between a weak acid, so if it's kind of staying in equilibrium, if you wanted to, you could mess the temperature of the solution. If you wanted more products to be seen, if you wanted to have a product favored reaction, you could increase the temperature of that solution, which would lead to more products being formed. Now that would be one way to help with your equilibrium situation. Also, Kristen, I did not mean to sound so rude at first impact. It just kind of came out. So another thing that I wanted to talk about is what a buffer is and how a buffer works. So for the first part, a buffer is when you have an aqueous solution that has like a highly stable pH. This is usually when you have a weak acid or a weak base. So once you put it into that solution, it's able to either take on protons or give off protons, whatever it needs to do to help stabilize your pH of that solution. So you would do this in situations where you don't want your pH to change a lot. This would be in biological terms. If you have, say for blood, for example, blood has to have a certain pH of 7.35 to 7.45, and there's certain buffers within the blood that will keep that pH in a normal state as long as it can. Going back to this video right here, you can see that I'm filling up a graduated cylinder. We are doing this just so that we can get a somewhat better measurement of the solution that we're going to be using to help our dilutions and everything. I don't really know what to fill these awkward bits of space with, so you and Kristen get me. You're welcome. That concludes that portion of the video, so now we have some bloopers just to add in. You can see here, dancing as usual, because why not? Just a very awful picture of us, and then just us having fun towards the end. Thank you.